Welcome to part 2. Now for part 2 we're going to take a look at a very special function. Now you're going to see this function quite a bit in calculus next year. So if we want to graph this function, it's the x over the square root of x squared plus 1. We're going to start it the same way. Again, you're going to look for anything with a domain restriction. Don't worry about the square root. We just really want the bottom to see if anywhere on the bottom is going to be 0. We don't have to worry about the square root because we're just going to square it anyways. So again, we're going to get x squared equals -1. If I try to take the square root, we have a problem. You can't take the square root of a negative. So there's going to be no domain restrictions here. So as a result, will there be any holes? No. Will there be any vertical asymptotes? Again, no. Now, there will be a horizontal asymptote. Now this one's a little bit trickier to find because of the square root. So what we do is we imagine a horizontal asymptote basically tells me what's happening as to the function. So here's my horizontal asymptote up here. It's what's happening as we go off to infinity, as x gets really, really large. Well, if we kind of imagine as x gets really, 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 really large, this 1 right here doesn't mean anything. So to get the horizontal asymptote, another way we can look at it just becomes y equals just basically x over the square root of x squared. We don't worry about the 1 because we're going really, 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 really far out into the future. Okay? Like if you take a billion and you have a billion squared and you add 1 to it, you're not changing it much, okay? And we're talking about infinitely large. So x gets really big. As the bigger x gets, the littler that 1 matters. So we can really write a horizontal asymptote like this. Now, how does that affect us? When I write it, we're going to get y equals x over, now what's the square root of x squared? Plus or minus x. And that's going to give us 2 horizontal asymptotes. We're going to get +1 and we get y equals -1. Now, again, just like when we did the absolute value one, when is it positive? When x is positive. When is it negative? When x is negative. So these are our horizontal asymptotes. Next, we just need a couple of points, okay? So let's see here. Let's get the y-intercept. Let x equals 0. Oh, that's easy. 0, 0. Let's get the x-intercept. Multiply here across. If this is 0, don't worry about the denominator, it just goes away. So I get x equals 0, 0, 0. Okay? So, easy breezy. So now when I sketch this one, it looks kind of really cool. This is kind of a cool little graph here. My only asymptotes are at 1 and at -1. And again, when is it -1? When it's less than 0. When is it +1? When it's greater than 0. My only point was 0, 0. Now, when I graph it, remember, functions are attracted to asymptotes, so they want to go toward the asymptote. So if I go to the right, it has to head towards the asymptote. Now, it's not going to go up. It's not going to go up because then it would cross it. It has to kind of go like a logarithm function or square root curve. Kind of goes like this. And on the bottom half, and it goes down like so. And there's our graph. It almost looks like a cube root graph. All right, so let's try another one here, okay? Again, try to find the domain. Okay, to get the domain, take that 9x squared plus 5, set that equal to 0, or not equal to 0. We would get x squared not equal to -5 over 9. And since we can't take the square root, no domain restrictions. So that means no holes, no vertical asymptotes, but again, this time there will be a horizontal asymptote. So let's talk about where we get a horizontal asymptote. Again, the horizontal asymptote deals with what goes on when we go into the future, way into the future. I'm letting x get so big, this 5 means nothing. It's kind of like, my old girlfriends in college. I used to make all the money, and they thought they'd be cool. Hey, here's $5 to chip in. No, it didn't help me any because I have way more money than you do. So we're going to write our horizontal asymptote as y equals. We're going to leave the 4x on top, and on the bottom we're going to get the square root of 9x squared because again we don't care about the 5 as we get really big. So what does this become? 4x over, be very careful, plus or minus, the plus or minus comes from the x squared. We don't know if that's positive or negative, 3x. And what cancels? Oh, those x's cancel right there. So we get the horizontal asymptote as positive 4/3 if x is greater than 0, and y equals negative 4/3 again if we're less than 0. So there's our horizontal asymptotes. And now we need a point. What's our y-intercept? And you're going to notice this right away again. Let x be 0. 0, 0. What's the x-intercept? Here's a hint. If the y-intercept is 0, 0, your x-intercept is always going to be 0, 0 as well. And now we can graph this one. So we're going to be up here at 4/3 and at negative 4/3. When is it 4/3? When you're greater than 0. When is it negative 4/3? When you're less than 0. And at 0, there's my point. What's it going to look like? Head towards the asymptotes, like so. Very easy to do. All right, let's take a look at one more. Number 7, okay? So, again, we kind of got the pattern. Now, in your homework, I want to show this. We'll take a look at the domain. We take 16x squared plus 7 not equal to 0. So we get x squared not equal to negative 7 over 16. And again, no domain restriction, which of course means no holes, no vertical asymptote. So let's go straight to our horizontal asymptote here. So we go y equals, just like we've been doing before, negative 5x. And again, when I take the bottom, it's the square root of 16x squared. We don't worry about the 7 because x is getting so big, the 7 just becomes basically infinitely small in comparison. So we do this, we get negative 5x over plus or minus 4x. Now, what does a negative over a plus or minus make, you may be asking? A plus or minus, but the negative will affect us because that's our vertical reflection. Okay, and we'll talk about that in just a second. So we get y equals 5x over 5 over 4, because the x's cancel, and we get y equals negative 5 over 4. This is where the vertical reflection takes place. Normally this would be the positive, but now since we're reflecting it, that becomes the negative, and this becomes where x is positive. So be very careful. And what's our one point? The y-intercept. Again, let x be 0, 0, 0. Our x-intercept, again, 0, 0. Not much room, but these don't take much. So we're at 5 over 4, negative 5 over 4. We switched them. That's what that vertical reflection does. We switch them. And now our graph goes like this. All right. So take a look at these, try them, and we'll come back tomorrow and practice a few of these. Now don't forget we do have a pop quiz tomorrow if you're Mr. Warrenow's class, okay? Thank you.